Welcome to this class. Today we are going to be talking about eigen values. And to begin with, I want you to try that problem. Find the eigen values of the following matrix. The matrix as shown on the screen for you to try it out. That is A is equal to 4, 6, 6, 1, 3, 2. -1, -4, -3. So I hope you are up and running and you're trying it out. Thank you for attempting. Now let's try it together. First and foremost, you have the characteristic equation to find, and you will see that as I have indicated on the screen, that A minus lambda I, where I represents the identity matrix, order 3, shall be given by 0. When you write it in full, it is going to be 4 minus lambda, 6, 6, 1, 3 minus lambda, 2, -1, -4, -3, negative lambda. Of course, when we find the determinant of that particular matrix, we are going to get the characteristic equation from which we're going to find the values for lambda. As you can see, we're going to express that particular matrix in such a manner that we are able to get the values in the leading diagonals less the values in the trailing diagonals. And as you can see, we have in the first leading diagonal 6, 1, and -4. And in the second leading diagonal, we have 4 minus lambda 4, lambda, 3 minus lambda, -3 minus lambda. And of course, we have 6, 2, and -1. All that is in the leading diagonal. So we're going to sum up all those values to be able to get our answers. So as you can see, I've indicated here the sum of the leading diagonals minus the sum of the trailing diagonals we're going to give us 0. And if you did that, you can see very clearly the multiplication process of multiplying the elements in the leading diagonal and the elements in the other diagonal. Clearly, you can see that the leading diagonal has 24 plus 4 minus lambda into 3 minus lambda into -3 negative lambda minus 12. How did I get that? I multiplied these values, that is 6, 1, and -4 to get 24. I wrote this expression as it is. And of course, I multiplied at the last, that is 6, 2, and -1 to get -12. I hope that is clear. In the other diagonal, the trailing diagonal, I have multiplied this to get 6 times 3 lambda, negative lambda. Then I have subtracted because -1 multiplied by 6 gives you -6, and that multiplies there to give you that. And of course, this is 8, -8, and that is okay. So the solution is as given. So as you can see there, a -24, -12 gives you -36, and this expression here is written as it is. And of course, opening the brackets clears out negative lambda 6, -6 lambda and +6 lambda cancel out. And of course, we have the resulting as -68 plus 8 lambda. On the right hand side. That is the trailing. And of course, the leading diagonal sum is given by negative that 72, positive 9 lambda plus 4 lambda squared minus lambda cubed. As you can see very well, we have our values there. This is the expression for the characteristic equation from which we are going to use trial and error to get the values for lambda. As you can see, we are going to do it trial from 0, 1, and 2. When we try out 0, in this equation, when you put 0 here and you put 0 there and you put 0 for lambda, you get negative 4, which is actually not equal to 0. So, of course, that is not a solution. When we try out 1, you get negative 1, positive 4, and positive 1, and negative 4, which actually give us 0. That tells you that lambda minus 1 is a factor. From where we do our long division. That is the long division I'm talking about. That is the long division I'm talking about. And you set it in such a way that it gives you the answers very clearly. Negative 1, you put it on the left-hand side. And the equation in lambda, you put it on the right-hand side. So once you do the first one, the second and the third, in terms of subtractions, for example, for me to get lambda cubed, I must multiply lambda by lambda squared negative. So if I do that, I'll multiply this part and this part because I'm going to get here to be negative 3 negative lambda cubed plus lambda squared. That is multiplying negative lambda squared by negative 1. It gives me that. When I do my subtractions, I get 3 lambda squared. Of course, I drop down lambda, as you can see. So the long division, when you follow it, gives you that as the resulting solution. And so our resulting solution in terms of the function of lambda is a quadratic expression. And that quadratic expression will use factorization, where the sum will give us negative 4 and the product is going to give us 3, as you can see. From where we have the factors worked out clearly, and of course that gives us our answers, as you can see. Of course, you can take your time and follow, and you're going to get the answer right. Thank you for following. Have a blessed evening.